Okay, yesterday we were working on basically converting mixed radicals to entire radicals and entire radicals to mixed radicals. Today we're looking at the multiplication and division of radicals. So I've got 3 root 5 and square root 10. Okay, so when you're dealing with radicals that are mixed, or even if they're entire radicals, you're working with the whole numbers first, and then your radicals, your square roots second. All right, so if I'm looking at this one right now, I look at it and I say, okay, I'm going to multiply the whole numbers first, the rational numbers. So there's 3 times 1, which is 3. Then I'm going to multiply the square root values, and I get square root 50. Okay? Now, my intent, again, like fractions, is I need to reduce these things so that I have the smallest possible irrational number that I can have within the square root. All right? So I'm going to take the square root of 50, for instance, and I'm going to break it down as well. So I'm going to break it down to root 25. Don't need brackets, but whatever. Times root 2. Okay? So that's equal to 3 times 5 times the square root of 2, which is equal to 15 root 2. Now, going back to the original equation, I could have also, and this happens as well when you do fractions, when you're multiplying fractions, you sometimes cancel them before you go through with the whole thing. So I could have rewrote this as 3 root 5 times root 5 times root 2, right? Which is what root 10 is. Root 5 times root 2. Root 5 times root 5 is what? It's just 5. And again, I still end up with 15 root 2. So however you want to do it, whatever you find easiest, okay, you select the method that you want to use. Now this one is a little more advanced for you. This one is just using what you've learned last year. Okay?
So that root 5 and root 2 is from root 10?
Yeah. Okay? Let's look at the next one.
Can you make it a double?
So I have 4 times root 14x. And that's times 2 7x cubed. Starting with the rational numbers, what do I get? 8. Okay? And then I get the square root of 14x times 7x cubed, right? So 14 times 7. Okay? Which is what? 98. X to the 4. Right, so far? Mm-hmm. Okay. But not simplified enough. All right? So I have 8. What is a perfect square that goes into 40? What goes into 98? That's a perfect square. 49, which is 7, right? And x, the square root of x to the 4th is x to the what?
3.
X to the what? 2. 2? 3? 2. What if I wrote it like this, Ty?
Oh, yeah.
Right? So what do I end up with? 56 x squared. Okay? Okay? All right, so all that happens now, okay, we just continue to work through these questions just the same way. So how do they get it more complicated? Well, they put a binomial by a binomial, in which you have to FOIL. So if you're looking at your page 200, 1D, example 1D, that's just foiling it. Okay, FOIL it, simplify it, and go from there. And then they amp it up a little bit more because they put a cube root in. Well, that doesn't change anything for you either. Go ahead.
The last one, like the 2, the square root of 2, and 4 and 2.
I have the square root of x to the 4th, right?
Yeah, but in the 98, then you split it up into square.
Oh, where's my square root 2? Very good. Yes. That's right. So that should have been square root 2 there. Nice. Time. Great. Okay. Okay, and that comes from 49 root 2. Okay, and that gives us 98. All right. Next example uses cube root now. 8xy squared times the cube root of, oh, should be a 3 in front of this. 3 cube root 8x squared y squared. Does that look right? Okay. Again, this is one of those times I'm going to probably, because of the variables in the brackets, I'm going to multiply it out first and then I'll simplify it. So I've got 7x times 3, 21x to start with. Those are my rationals. Those are on the outside. Now I have the cube root of 64 x cubed y to the 4th. All right, so here's where yesterday is going to come into play for you today, where it's going to be extremely important to you. All right, so I still have 21x on the outside. What is the cube root of 64?
8 or 4.
4. 4 times 4 times 4. So that actually breaks down. So we got that one. What's the cube root of x cubed? Just x, sure. Put that in there. What's the cube root of y to the 4th?
4 over 3. Y to the 4 over 3.
Yeah, okay, but we don't want to rewrite it with that exponent. Okay?
Why would you like you did with the
Yes.
the brackets?
Yes. So what do you think it is?
Y, like brackets y to the 4th and then
Oh, I see. Yeah, you're doing the same thing as what Taiwan. So I put that as 4 over 3.
no, but you put it in the brackets before or did it the x and put a half like that.
Wouldn't you just,
Or 1/3 on the outside. Or 1/3.
wouldn't you just leave it as
Y to the 4
to the 4?
in brackets to the 1/3.
Okay, that's good. I'm on the same page. So I got that, right?
And then it's 4 to the 3.
And it's what?
That's 4 to the 3.
Yeah. But I don't want to write it like that.
Wouldn't you just leave it in the cube root? and put
Okay,
y?
so let's go back. Let's do this. Let's go back to what we did yesterday. Okay, so this is exactly what we did yesterday.
There's 3 and 1.
Yes, that's right. Very good, Gene. Correct? All right, this is what we did yesterday. I want to find out how many 3's I can get out of this. Okay?
1.
So there is. Right? Y cubed. Y to the 1. That is actually y cube root y. Agreed? Yes. Okay, it's exactly what we did yesterday. So now if that's the case, then I have this. 82 x squared y cube root y. Okay? 21 times 4 is 80, should be 84, not 82. Uh-oh. 84, x times x is x squared. We took the cube root of y out of there, which is y. Cube root y is what we have left in the brackets. Okay? Exactly what we did yesterday. All that we're doing is we're adding the extra step of multiplying. Fair enough? Okay, so we're done multiplying. What's next? Again, you can only work with these provided they're both under the same root value. All right, if this was a cube root up here and a square root down here, you can't do anything with it and leave them. But if the roots are the same, then you can multiply and divide inside the roots. So what does this equal? 15 divided by 5 is 3. X divided by x is 1. I leave the root y. Okay? These ones also, again, present a problem in the sense that we have a restriction. To that. Okay? We have to announce that basically when we solve it, that x is greater than 0. And in this case, y can be greater than or equal to 0. If x is 0 down here, I get 0 times 5, which is 0. What's the square root of 0? 0. But what's the problem with that? Where's that 0 located? On the bottom. Can't have it on the bottom of a fraction, right? So this one has to be greater than 0. Okay? And it has to be greater than 0 because I can't have a negative number in here. Right? It's negative, then I get square root of a negative number. So these restrictions now have to be part of your solution. All right? Look at another quick example. I'll look at the quick one, and then I'm going to look at this other one here. Square root 5 over 2 root 3. Okay? What does this work out to?
Wouldn't you have to divide it into 2 first?
Yes.
So
You're right. Yeah.
4
4 what?
root 5 over 3.
Okay. What do we learn that we have to do with that, though? Yes. Okay? We don't want square roots in the bottom of fractions as well. All right, we learned that last year. So we want to rationalize the denominator. How do I rationalize the denominator? What is the square root of 3 divided by the square root of 3?
1.
It's 1, right? So if it's 1, then I'm not changing anything, am I, by multiplying this? But it allows me to get rid of my denominator down here being a square root, right? So 4 root 5 times root 3, 4 root 15. And what's on the bottom? Root 3 times root 3. What is root 3 times root 3? Square root 9. Square root of 9? 3. So we now have to rationalize all our denominators. And we do that by multiplying the top and the bottom by whatever is down here. With the exception of one thing. Is there any questions about this? Because I'm about to get a little bit more complicated on you. We understand this concept? If you have a square root on the bottom, just multiply by the square root. Top and bottom. Because that's 1. Alright? So I said I'm going to get more complicated. Here it comes. I want to rationalize this denominator. So what am I going to multiply by to rationalize this denominator?
5 root 3 minus 10 root 2.
What do you got, Courtney?
So 5 root 3 subtract 2 root 2.
So I'm going to multiply by the same thing. We agree? Do we agree? Yeah? Okay. Don't write this down, because I disagree. But you're very close. So I'm going to show you why we don't do it this way, and then I'll show you the quick fix. Okay? No.
Do something with 7.
No. Here's a quick fix, all right? I'm going to show you why this isn't going to work. My whole intent here is to get rid of the square root on the bottom, right? So she's not far off on this. But watch what happens. Let me just change the question slightly. If I take root 5 minus root 2, and I times it by root 5 minus root 2. Okay, I have to FOIL that, correct? It's a binomial by a binomial. All right? What's root 5 times root 5? Right? Outside. Root 5 times root 2. Inside. Correct? Okay, so I would have ended up with that. So very close. Very, very close to getting rid of it. But not getting rid of it. And I couldn't just multiply this by root 10 after either, because that would give me 7 root 10. So you're on the right track. You're very, very close. All right? So what am I going to do? What's the quick fix here to make this happen? Yes. When I take a minus b and I times it by a plus b, what do I get? A minus b, a plus b. What do I get? What do I get? Difference of squares. So what's the final solution then? A minus b times a plus b is what? Difference of squares. What does that mean? What is the answer? A squared minus b squared. Right? So what have I done? If I put a plus here and a plus here, right? I'm going to get this squared minus this squared, which is going to what's going to happen to my square roots? They're going to disappear, right? So multiply across the top. 35 root 3 plus 7 root 2. On the bottom, I have 5 root 3 squared minus root 2 squared. Okay? 35 root 3 minus 7 root 2 over 25 times 3 minus 2. Root 3 squared is just 3. 5 squared is 25. Root 2 squared is 2. Final answer? $75 minus 2? 73. There's your solution. All right, so there's got to be some sort of rule that I can match up with this. All right, and it's simple. When you have a binomial on the bottom, something like that. Okay? I'm going to multiply by its additive inverse. It's called conjugate. You multiply by its conjugate. What does that mean? You take this times it by, so you're going to take this whole thing and multiply it by this, subtract that. If it's a subtract, you're going to multiply it by this plus that. Real simple. Okay? Because you're going to always end up with C squared minus P squared. I've told you from the get-go, we have to remember this difference of squares. And it's now showing up again. Right? So far, all we've done is work with polynomials, difference of squares. Now you're doing it again with radicals. So it's very, very important that we always remember working with difference of squares. Okay? That's all I have. I'll answer questions.